Hey, my name is Jackie Yuan. I'm going to talk about a very basic topic in causal inference. In causal inference, we often start with one question. What is the average treatment effect? For example, if we increase the price of ice cream, what happens to sales on average? Right? This is a very useful question. But in many business cases, that is not enough. Okay, so here I have the data, a very dummy simple data right here. We have temperature, weekdays, cost, price, and sales. Okay, so as a business owner, we always care about the sales, but we also want to raise the price so we have a good amount of the profit. So, but we know maybe raising the price hurts the sales on some days, but barely matters on the others. Maybe on a higher temperature day, increase the price of the ice cream, maybe even bring more sales. So maybe customers are more price sensitive when the demand is low and less sensitive when the demand is high. So today, I want to show how we move from ATE, the average treatment effect, to CATE, the conditional average treatment effect. That is the foundation of heterogeneous treatment effects and personalization. First, let's set up the causal setup, which is very basic: X, T, and Y. X means context right here. We're going to choose A, B, C column, temperature, weekdays, and cost. So this is our context. So keep in mind, the treatment will be the price. We want to understand if we increase or decrease the price, how that affect on our sales, which is our Y, the outcomes. Okay, so keep this in mind. And let me go back to my notebook. So we're gonna run a very first simple regression model. So in this model, right? So we just run a very simple model, and we're just trying to understand, okay, if what is average treatment effect, okay, and this just basically saying, okay, after I control for temperature, weekday, and cost, what is the average relationship between price and sales? And that gives us something very close to an average sensitivity, right? But it does not allow different days to have a different price sensitivity. So basically, that's a average sensitivity, right? So just for example, let's look right here. So this just the coefficient of the price basically just means if we increase the price in 1 unit, the sales will decrease by 2.75 unit. Okay, so that's just basically the average treatment effect. That may be useful, but this is not the topic that we want to focus on today. So we want to move from ATE to CATE. Okay, and that's why I also created a interaction model. So first, I want to also add in is the first simple regression model we created. The R square is only 0.511, which is not that great. And in the M2, I also just adding one more interaction terms right here, which is the price and the temperature. And you will see there's the price and temperature right here, and we also see the coefficient right here, and this just indicating us, okay, when the temperature increase, this is also kind of explaining the increase of the sales. And the R square here is not super great as well. It's barely increased a little bit. Okay. So the interaction terms, so basically, in my opinion, are not just the technical declaration. In this context, they are how we let the treatment effect varies with our context, which is X. Okay. And I'm going to move to the M3 regression that I created. So basically in this regression, right, so I basically let the price and cost interacted together, price and the weekdays interact together, and also price and temperature to interact together. So you will see a lot of heterogeneous effect underneath with different coefficient um, to that will actually affect our finals. Okay, and also create a predict sensitivity function right here. So this is kind of like the heart of the notebook here. So what this function do is for each row, okay, so we make two prediction. So first, okay, first we make the prediction of the current price, okay, and then we predict the sales if we increase by 1 unit right here. Okay, so the difference is in the estimated sensitivity. So if the value is -10, for example, the model predicts that raising price by 1 unit reduce the sales about 10 units. And if the value is close to 0, which is great, so which means that they is less price sensitive. Okay, notice the causal logic right here. Okay, we're not simply predicting the sales. We are asking a counterfactual questions like difference in difference. What would sales looks like under a different treatment value, which here is we increase 1 unit on the price. Okay, so once we have the predictive sensitivity and we can actually segment the days into group. So right here, I just for example, I just segment by 2 groups right here. Okay, so and we will notice that some of the days are highly price sensitive, and some of the days are less price sensitive. So and the days that are less price sensitive, let me give examples for example right here, and those are the better candidates for a price increase. Okay. And I also created a machine learning model, very simple machine learning model here, and I didn't change anything here. So the comparison is actually also important. Okay, so the machine learning model is only purely predict the sales. Okay, so you can actually treat this more that we use a more advanced regression model behind it compared to the M1 just using an OLS. So what matters here for the decision here is a day with a high predict sales is not necessarily a good day to raise the price. Okay, so what matters here is for the decision is not just the level of sales. What is matter is the response to the treatment. So this is the causal inference mindset. And let me show you the two charts like right here. The first one is using our causal inference model. So you will see in the more sensitivity price group, when the price increase, the sales kind of like drop down when the price increase. And on the less sensitive price group, actually even we increase the price a little bit, the sales actually slightly increase. Is that amazing? And on the second chart right here, that is only purely the machine learning model where for both groups, the sales, the price increase, the sales kind of like a decrease as well. So that is the causal inference mindset I want to share with you guys. So optimize decisions based on the treatment effects, not just predict outcomes. Okay, so for business perspective, okay, so what this teaches us? So this gives us a very simple decision framework. Okay, so if a day is highly price sensitive, we should be careful about raising prices. If a day is less price sensitive, we may want to test a higher price. This is personalization, but grounded in a causal inference behind it. So we are not personalizing because the model says the sales are high. We are personalizing because the estimated treatment effect is different across contexts. Here again is temperature, cost, and weekdays. Okay, so this is a key distinction. In the future, I will also talk more about the heterogeneous effect, for example, the uplift modeling in marketing, and also the subgroup analysis under the A/B testing as well. So if I hope you like the video. If you think that helps you a lot, please subscribe my channel or my account. And if you have any question, leave in the comment. Thank you. See you next time.